Dolphins, parrots, chimpanzees are not in that situation. There's no pressure for them to become more like humans. It's no advantage to them. When you ask yourself, why did it take 4 billion years for language to evolve? One answer you might give yourself is that language is rubbish. Maybe it's no good. I think there's a lot to that, actually. I think language is a very expensive thing to maintain. Our brains, our huge brains, are largely devoted to language. And
yes.
Why do you need it, right? Why would an animal waste so much energy and so much of their body for something that maybe doesn't help them all that much? So really, it's more that our ancestors were the weirdos. Our ancestors were unusual in that they could have benefited from language, whereas most other animals, it's just not that useful. It's not that useful, and that's why it hasn't evolved.
My guest is Dr. Arik Kershenbaum, a globally renowned zoologist and researcher at Girton College, University of Cambridge, specializing in animal communication and astrobiology. He's also an international best-selling author for his book, The Zoologist's Guide to the Galaxy, as well as his more recent book, which is one of my favorites, Why Animals Talk: The New Science of Animal Communication. His research focuses on the evolution of complex communication systems in animals and the implications for understanding the origins of human language, as well as our own intelligence and even extraterrestrial intelligence.
One of the things that you often hear science fiction theorists talking about, or even people who think about life elsewhere in the universe, is surely, given the age of the universe, surely other civilizations are more advanced than us, or at least there are some other civilizations that are much more advanced than us, not just 100 years, but maybe 1 million years more advanced than us, or 100 million years more advanced than us. And if you think about what AI would be like in 1 million years, it's an inconceivable amount of time. But I think even you would agree that in 1 million years, AI is going to be pretty good. But then when you had urbanization, when you had the scientific revolution of the Enlightenment, and people started to say, hang on, we are different from nature. What makes us different from nature? That was when humans really started to distance ourselves from the rest of the world. And, at our peril, because any city dweller who relies on their food from the supermarket doesn't need to think at the moment where that food is coming from. Whereas the farmer 1,000 years ago certainly knew where their food was coming from. And that's where that disconnect becomes dangerous, because people feel that they don't need their environment. They do. They certainly do.
This is a CEO Retort podcast, the show that fearlessly goes after the difficult topics that we all need to talk about, campaigns for issues that we're all concerned about, and invites some amazing, inspiring, and remarkable guests who will help us navigate through this fragile world that we all care about. I'm Tim Al-Sheikh. Let's get after it.
You are listening to CEO Retort.
Arik, I read your book, which I think is brilliant, and I encourage people to read it, about how if animals can talk. You've got another book that I haven't read yet, but we'll get into that later. But I think it's really, really cool. Zoologist's Guide to the Galaxy. I think that's like the best title ever, in my opinion. But as we just alluded to just before we started recording, I want to talk about our understanding of intelligence, because you explored how animals communicate and whether they have a language, etc. But one of the things that I really liked about your book is that you've questioned our own understanding of intelligence, and in terms of what we think it is, and the fact that we look at animals through our limited understanding of intelligence makes people think that animals have zero intelligence. And you alluded in your book that throughout history, humans really mistreated animals as if they are just commodities. I actually see that today in industrial farming, right? Animals are not seen as living beings. They're just things that exist. Some biological monotonous robots. But of course they're not. And I think you've explored that quite beautifully in your book in terms of how they communicate. And like I said, we're going to explore that. But can we start the discussion on this foundation first, in terms of what is your point of view of how our understanding of intelligence, especially in a world where it's all about AI and artificial intelligence, which is, I challenge the interpretation of that. But I love the fact that you've challenged it from the point of view of zoology, because it just shows that the natural ecosystem of living beings, us included, is way more complicated than chatbots, for example.
Yeah, because we there is there's a continuum of how humans think of intelligence and how humans think of animal intelligence, and there's certainly some people who think that, as you say, animals have no intelligence, that they are just mindless robots, and there are some people who think that animals are as intelligent as we are, and a lot of it a lot of the problem there arises from the fact that humans have struggled traditionally to define intelligence anyway. Intelligence in humans. It's a very controversial topic. It's not. It's not something that's got a particularly illustrious history. People using definitions of intelligence that suit them to include or exclude groups that they want to include or exclude, and that's really. I think that the understanding that people have come to, that educational psychologists have come to, over what human intelligence is, sheds a lot of light on what animal intelligence is, because we know that human intelligence doesn't seem to be a monolithic thing. It is a series of abilities to solve particular problems. There are people who have mathematical intelligence. There are people who have hand-eye coordination, gaming intelligence. There are so many different kinds, and each of them addresses a different kind of problem. Now, that's exactly what has happened to animals over evolutionary history. That intelligence, all animals are intelligent. All animals have some kind of intelligence. It's the nature of what animals are. And over billions of years, they have evolved to leverage different kinds of interpretations and understandings and manipulations of the world to solve very specific problems: finding food, avoiding predators, building structures, cooperating. These are all things that answer very specific needs, but they're all different things. So you can only really understand intelligence in animals if you understand the totality of tasks they have to perform.
So effectively, their intelligence is it that their intelligence was designed genetically in order for them to fit within whatever ecosystem that they live in, or is it more like the ecosystem evolved their intelligence over time?
They're not designed. I mean, all of this is evolutionary rather than design. But it's a combination of both, really, because as ecosystems became more complex, 1 billion years ago, let's say, a bit less than 1 billion years ago, as ecosystems became more complex, there were more kinds of organisms. There were different kinds of organisms that moved and that didn't move, and that used sunlight and that ate other organisms. Then there are different ways of there's so many different ways of interacting between these different organisms that new approaches, new solutions to classic problems became highly advantageous. So let's say that you're swimming in the water 700 million years ago, and you have some sort of eyes, some sort of sensors that can spot what's going on around you. You can see if someone's coming to eat you. But those organisms that can detect predators coming to get them faster will have a certain advantage. Now, where do our brains come from? Where do animal brains come from? Almost entirely from that, right? From being able to detect predators coming to get you, and from being able to find your food through looking at them. The early brains are the result of new innovations that can take advantage of the ecosystem better. That's what evolved into intelligence.
Yeah. I mean, the reason behind my question, because of course there are religious beliefs out there that basically suggest that, we were all created as we are. There's no such thing as evolution, etc. But of course, science is showing that we all have some kind of a common ancestry that we all, I mean, you look at, obviously, from my point of view as a biologist, when you look at how the fetuses, how they develop, they practically look identical across all mammals, right? You can't tell the difference between a human fetus and, I don't know, a cow's fetus, okay? Like, they're at such an early stage, it kind of looks like somehow we've all, we were created by that one template, and then somehow we just evolve into all these different directions, which kind of, in my view, I mean, I go on this purely an opinion, nothing to do with any kind of scientific knowledge, but I feel that there's like some kind of like a collective consciousness, not in a kind of sci-fi way, but it feels like, we are part of an ecosystem. And again, because as humans, we tend to see ourselves as, exceptional, right? Everything revolves around us. And somehow, we're at the center of the universe. So people used to believe that we were at the center of the universe until we realized that we weren't. But we see that even today, that humans are at the center of Earth and Earth's ecosystem, and everything revolves around us. But from your work and basically what you've just highlighted, it just suggests that actually we're all part of the same ecosystem. We're just playing different roles. We just happen to be, well, I don't know if it's intelligent enough or stupid enough to build very powerful weapons and destroy Earth, right?
Yeah, it is a really important point to remember that we are no more evolved than any other creature that lives on this planet. We all are descended from the same organism that lived almost 4 billion years ago, the first life that gave rise to everything that we see around us, plants and animals and bacteria. Everything comes from this one ancestor. And complex humans, giraffes, mice, fungi, mushroom in your garden, they've all been evolving for those same 4 billion years. So what's been going on? It's a reasonable question to ask. What's been going on that humans seem to be so complex, and a blade of grass seems to be so simple? How can it be that they've both been evolving for the same 4 billion years? But that's really, that understanding is at the core of understanding who we are and where we are. It is that we have evolved to take advantage of certain aspects of the environment, and a blade of grass has evolved to take advantage of other aspects of the environment, and it does it just as well as we do, perhaps better in some ways, as you pointed out.
Yes, which brings us nicely now to the communication aspects of it, because of course, I mean, I get into, not regularly, but I do get linguists, attacking me when I say in relation to large language models with AI, because they believe that because machine learning now has the ability of kind of human level interaction, right? Because the language side of the AI models today is so powerful that you can converse with it. Therefore, it's conscious. Therefore, it's intelligence. And I kind of always argue with them and say, well, the fact that we can talk doesn't mean that we are intelligent. I mean, parrots can talk. I mean, parrots were a big feature in your book. And there's a whole argument about AI is much more, they're more like stochastic parrots. But I made an article, actually, I wrote an article that actually parrots are smarter than AI. So I think, shall we get into that first in terms of the whole language side of things? I mean, do animals talk? Let's start with that, which is basically the key concept around your book.
Yeah, well, all animals communicate, just as all animals move, with a few minor exceptions for various reasons. But essentially, what an animal is an organism that moves around to find food. And as soon as it moves around, as soon as organisms move around, and they're not in the same place, then there's a huge advantage to communication. So all animals communicate. Everything, snails and beetles and everything communicate. All animals communicate. But that doesn't mean that all animals have language. Now we have a problem is how we're going to define language. And here, people can be quite adamant that their cat talks to them in a language. And we have to be modest and say, I'm not going to define language for you. If you want to define language in any particular way, then I'm happy to do that. I have a particular definition of language. I think that to be considered language, something has to be unlimited, unbounded in its expressive ability.
Right.
So we know that human language is unbounded. We can see all the books, we've not written all the books that can be written, and we never will. There's no limit to what can be said in human language. And that's not the case for any other animal species that we know of. So we know that all animals communicate. In many cases, we even know what they're saying. In many cases, we know what kinds of messages they're giving. But even in the most complex cases that we're aware of, the kinds of messages that these animals are conveying are only a very small number of concepts. 10, 100, doesn't matter. Even if it's 1,000, it doesn't matter. It's not unbounded like human language is. And I think that is a distinction that is worth preserving. I think it is important to say, hang on, what humans are doing is different from what animals are doing. And let's call that language. Let's call this unbounded thing language, which is not to say that what animals are doing is somehow less effective or less beneficial. For them, it's extremely beneficial. Exactly. Parrots are an excellent example, because parrots appear to have the ability to learn an unbounded language. There's some evidence that they potentially could do that, but they don't. Which is a good sign that, language is great. We all think language is great, but that doesn't mean it's great for all species. It may not be useful for parrots.
It's a tool, isn't it? It's effectively a part of the communication arsenal, isn't it? That you've got because you look at animals, like, for example, I'm thinking about our cat. You see cats and dogs, their body language is a form of communication. So it's not just the barking and the meowing, but the way they move their tail, the way they, roll around, the floor or whatever. That is all part of their communication, and try to portray something or convey a message of some sort. But we have the ability to speak it out more.
It's not just a question of whether it's spoken or visual. It's a question of the precision of what's being said. So I can look at my dog, right, and I can know whether she's happy or whether she's sad or whether she wants to go out. But those are not very precise concepts. So there's no way that my dog's body language will write a maths textbook or something like that. That's not going to happen. And what we see, in fact, in many species, in a lot of primates, for instance, is they have very complex communication. They do convey a lot of ideas, but those ideas are not necessarily precise ideas. They're more emotional. It's very important in any social animal, any animal that lives in groups, to convey emotion. Am I angry? Am I happy? If you come near me, am I going to groom you, or am I going to bite you? These are important things to know. So that kind of emotional communication is very, very, very widespread, but it's not precise enough to be called a language, I would say.
So it's more instructional, isn't it? It's about, I'm giving you an instruction to do this. Like, if I want to mate with you, or I'm going to attack you if you attack me, that sort of thing.
I think remembering again that none of this is designed. All of this is evolved. So it's a question of what produces some sort of benefit to the animal that's making that's sending the signal. And there can be a lot of benefit from just expressing vague emotions. It doesn't necessarily have to be as concrete as I want to mate with you. It can simply be expressing the level of anxiety, for instance. Think of a group of animals, perhaps, and maybe there are predators around. Then to be able to judge, are the other animals in my group anxious? Are they relaxed? These are very, very useful signals. And this is really the core. This is the origin of linguistic ability, is when animals live in a group that it's beneficial to know what the others are thinking.
Yeah, and you've highlighted actually quite well in your book, especially you used wolves and dolphins as examples. So can we start there? Because I will ask later on in terms of the choices of these animals. Like Hyrax was my favorite, actually. I thought that was a very interesting animal. But going back to the point in terms of how animals effectively survive in groups and the purpose of communication. So can we, sort of, without giving spoilers from your book, but what did you see the similarities that in wolves and dolphins? Because it's remarkably similar, isn't it? Again, it's all part of not a plan necessarily, but there's a pattern again. Very, very similar pattern, which is quite bizarre.
Well, it is surprising at first glance that wolves and dolphins make very similar sounds. Now, they don't sound very similar when you listen to them, but that's just because dolphin whistles are much higher pitched and much shorter and in length. And in fact, if you slow dolphin whistles down, then they sound just like wolf howls. Now, the reason for that is nothing mystical. It's nothing to do with design. It's just physics. It's all about what techniques are available to convey signals acoustically in a particular environment. And in the environment that dolphins live in underwater, in the environment that wolves live in, where you're communicating over many, many, many kilometers, then there are particular acoustic tricks that you use to make your communication effective. And that is just a question of the wolf lineage and the dolphin lineage, despite the fact that they are, they shared a common ancestor tens of millions of years ago. They've both found a similar solution to their problem, because physics is constraining. The world is not infinitely variable. There are only so many things that you can do. There are only so many ways to do it. So we see this often. We see it a lot in evolution. You see this convergence of different lineages coming across the same solution or very similar solution. It's very common.
And the interesting thing about wolves and dolphins, it's also the relationships, because that goes back to the question about intelligence, because they seem to have hierarchy as well, isn't it? Like, I wouldn't say sort of like politics, which we actually see in chimpanzees, which is kind of another fascination that I have. But there's definitely it kind of like humans, in the sense that we're very good at creating groups. Like, we're kind of have this for humans it's cognitive bias, I suppose. But with dolphins, for example, if they're all relatives, they stick together and they know that they're relatives, which I think that's very interesting, because you see with other animals, I don't know if they know that they're relatives. Like at the beginning, like a mother knows that, her cubs are her cubs, but then once they grow, that's it. It's like as if, that connection is severed somehow. But with wolves and dolphins, that's not the case. Is that right?
So yeah, it's as soon as animals live in groups, then there are complex relationships going on. And that's the same with humans, and it's the same with dolphins and wolves and with beetles and whatever, ants. The moment that a number of organisms live together, there are opportunities for cooperation, but there are also conflicts. There are always conflicts of interest. Now, how do you resolve those?
They understand that. And they understand that. I think
they don't necessarily
understand. Autonomous thing. Oh, right. Okay. That's interesting.
It can be an autonomous thing. It absolutely can be. And
oh, wow.
I'm sure we'll talk a little bit about consciousness and what consciousness is. But
yes,
whatever you think consciousness is, I think we can all agree that a dog or wolf has more consciousness than an ant. And the neurobiology of ants is really very, very simple. And it probably doesn't support the kind of consciousness that we're familiar with in humans. And yet, ants behave in a particular way that allows them to live in a group and to cooperate in a group and to resolve potential conflicts that exist in that group. Now the nature of the mediation of those relationships in ants is much simpler than it is in wolves, largely because of that cognitive dimension. The moment you think about things, the moment you think and you understand about things, then more complex interactions are possible. But yes, of course there are. If you have a number of wolves in a group, they all want to eat, they all want to mate, and so they can't all eat and they can't all mate. So there's a conflict of interest. How those conflicts of interest are resolved depends very much on the niche that they live in. If, as with wolves, no one can survive unless they cooperate. Everyone stands to lose if no one cooperates. So there's a balance, there's a trade-off. You have to cooperate to survive, and yet you want to be more successful than the other animal. And this is precisely where those complex social interactions arise. And Yeah, and take it to the extreme, of course, and you see what happens in human societies, which are incredibly complex and structured in so many levels, in so many dimensions of kinds of hierarchies, kinds of interactions, kinds of permitted interactions and forbidden interactions. This huge complexity arises from our greater ability to perceive and think about the world and different ways of working in it.
It's interesting, yeah, because with humans, it's like there's this obsession with power, isn't it? It's like, oh, I want to be powerful, the powerful leader, or I want to conquer the world and all of that stuff. I mean, you don't see that, for example, with wolves. I mean, like they do have, the lead wolf, right? But it's not necessarily political, is it? It's like, how do they decide who the leader is, for example, in
firstly,
the pack of wolves?
Firstly, you mentioned cognitive bias, but there's a huge selection bias here. When you say like everyone wants power and wants to rule the world, actually it's that small subset of people who want power and want to rule the world who are the ones who shout the loudest and you hear about. I think when you go down to the supermarket and you see people doing their shopping, I don't think any of them want to rule the world. Most people don't. It's simply not. It's just the loud ones who you hear about that power is so important. In fact, for most humans, as for most animals, the most important thing is to get on and to do well for yourself. And this is what motivates most people, and this is what motivates most wolves. You ask how they choose the leader. So the other thing to remember about wolf packs, most wolf packs are family groups. Usually there is a breeding pair, and their offspring remain with their parents for however long they remain, and then perhaps dispersing later. But usually wolf packs are very, very closely related. So these are family clans, and in most cases it's the eldest. It's the breeding pair that are the ones that call the shots, essentially. But not always. The other, talking about cooperation and families, is that in wolves you often see outsiders coming and joining a pack who are not related to the breeding pair, and the fact that works as well is actually very interesting. I mean, it's very interesting from an evolutionary perspective. But what it does show is that everyone stands to benefit from having a larger pack. It's in everyone's interest. You can fight off your enemies better. You can hunt better. So even though it's really a core family business, outsiders often do join as well.
So that's interesting, actually. So how did they make that decision? So an outsider wolf comes into a pack. How does the pack know that this wolf is a friend or a foe, as it were? How do they know that this wolf wants to be part of the pack to help out? How do they? It seems as if there's some sort of negotiations going on in there.
I mean, there always are negotiations, of course, in all organisms. All organisms have various forms of negotiation, even if they're not conscious negotiations.
That's fascinating.
But it comes back to what we were saying before about communication of emotion, communication of disposition, communication of intent. These are things that this is information that is transmitted between individual animals. So a wolf approaches a pack, and it's pretty obvious from the beginning whether the pack wants to be friendly, whether the lone wolf wants to be friendly. This is precisely why there is so much communication in animals, because these are really important decisions.
It's the body language, isn't it? Basically, it's the body language, so they can tell from there.
Sure, but sometimes it's other communication channels. Sometimes it's sound. Sometimes it's smell. They make use of all those different ways of communicating.
And do you see that across all animals that live in packs? Like you see, sort of packs of elephants, for example, and lions absolutely. And lionesses. Is it basically the same across all of them?
So, although I said that communication is common to all animals, it's unquestionably more pronounced in group living animals. Absolutely, yeah. You see that across the board. across the board. The more
Yeah.
complex the society, the more complex the communication, for sure.
That's interesting. I just had a thought in my mind because as you were describing all of that, because obviously I'm comparing it to the way humans do things. So it seems like as if going back probably to the point I made earlier that we are part of this sort of like a blueprint of some sorts, right? Like that we all seem to be following that blueprint. But I guess humans are more consciously aware of these blueprints, right? So animals are not like animals are just following it because basically they don't question it, right? So they're doing it without questioning. But we question everything all the time. And I'm wondering, is maybe that's why we try to figure out the meaning of our existence. We're trying to figure out, why do we have this blueprint? Who even created the blueprint? And all of these interesting questions. So I guess the point I'm making seems that, we live our life the way we do, not because our intelligence drives us, but rather we're doing it anyway by nature. But our intelligence, whatever that means, just kind of tries to question it more than the animals do, which kind of makes our lives more complicated.
Yeah. Yeah. It's a big mystery. It's something that we would all love to understand what makes us different from all other animals, if anything. Mm-hmm. And it seems that there is something that is different. There's something about our consciousness that is substantially different and leads to precisely what you described, that we do. Mm-hmm. We do ask questions, we do question things, we do wonder about things, and all of this appears, we don't know the real answer and why this is, but
yeah, we
kind of think that about 1 million years ago, something happened in our ancestors, and something to do with the complexity of the societies in which they lived, and our ancestors' brains began to change and to evolve and to have new capacities, new abilities that their ancestors didn't have. One of which, probably the most important of which, was a sense of self and other. And the moment that you have a sense that I am me and you're someone else who thinks different things, knows different things, then the complexity of interactions between individuals changes. The way we think about things changes. If you take an animal that doesn't have a sense of self and other, they can't really ask questions about why am I, why does my fetus look like a cow fetus? But because they don't have that sense that these are two different things. And if you think about the way you think about the world, it's absolutely all the time, absolutely full of this idea that here are individuals with individual thoughts and individual ideas, and they're all different, and they're all thinking different things. And that is what drives human curiosity. That would seem to be the big leap that was made in our ancestors. And somehow it's very tightly connected to language. Somehow those two things appeared to evolve together very rapidly, at least.
Yeah. So it's basically it's a sense of identity, isn't it? It's like, we exist for a purpose, as it were, as well.
No, so I think you can't even ask, do we exist for a purpose until you have the concept of we. The first thing is the concept of me and you. Self and other, two different entities. Once that has evolved, and that probably evolved for very practical reasons, it probably evolved because it gave our ancestors certain advantages, probably political advantages. We were talking about chimpanzees, probably advantages in how you navigate your social interactions in a group. If easier to navigate those social interactions if I understand what others are likely to do. That's probably the evolutionary driver for it. But once that evolved, then it's like the floodgates were opened and so many other cognitive abilities came after that. Like wondering about why I'm here and who I am and things like that. But those are consequences rather than causes.
And are there any other animals that close to that sort of way of thinking in terms of, I exist for a reason?
Well, we've got good reason to believe there are some other species, not many, but some that do have a very at least a very rudimentary sense of self and other. And you can test that You could do experiments, mostly experiments to do with whether animals know that other individuals have different information from them. Because if I know that you know something that I don't know, then I have a sense that you're a different entity from me. And that's not a very common ability, but we think that chimpanzees have that. We think that dolphins have it. There are some species out there that where you can do those sorts of experiments, and you can get a sense that, yeah, they sort of have that ability. And again, it's not surprising, because in highly political societies like chimpanzees and dolphins, then there is a huge advantage to knowing, well, I know that Fred over there is hiding some food, and he's going to tell this one, but not going to tell that one. Those kinds of interactions become very advantageous if you can do it.
And is it possible to effectively, maybe not necessarily explain our evolution, but from your work, studying these interactions between animals, what does it tell you, or does it tell you anything about our own evolution? It's like, how, where, how did we start from, like a single cell to where we are today, based on your observations from other animal interactions?
Yeah, we have a pretty good idea of how humans and all other organisms evolved from that single cell ancestor 4 billion years ago. And the reason that it's relatively easy to know this is through bioinformatics. And we can see the branching tree of evolution, because what that means is that if I want to understand why humans are like humans and not like wolves, I don't need to go 4 billion years into the past. I only need to go 60 million years into the past, when wolves and humans diverged evolutionarily. Everything that is different between me and a wolf happened only in those very recent few tens of millions of years. If I want to know what makes humans humans, really what I want to know is I want to compare a modern human with the last ancestor that we had who was not human. But I can't do that because they're extinct. I'm never going to meet one of those until we invent a time machine. But the best I can do is to look at animals like chimpanzees, who only diverged from humans about 6 million years ago. Only 6 million years ago. Very, very, very recently. Everything that is different between chimpanzee and a human happened in those 6 million years. That's all I need to study if I want to study what's special about humans. I don't need to go any further back than that, because of this branching tree. So when I work on language, and I know that humans have language and chimpanzees don't seem to have language, then it's that's where the interesting stuff has happened in that divergence between humans and chimpanzees. That's what I need to study.
That's
now,
interesting.
The fact that there's other animals that we're also interested in, like dolphins and parrots and things like that, who are completely different from us, that's also an interesting little clue, because as I mentioned with dolphins and wolves sounding similar, these other animals, despite being very, very much less related to us than chimpanzees are, have sort of stumbled on similar solutions. And that reveals a lot about what the possibilities are and what the difficulties are.
And as you said, also the environments are so fundamentally different, right? I mean, dolphins, live mostly in water and wolves don't. So they had to kind of adapt to the environment as well.
Yeah. And the environment is a constraint. It's sometimes you get frustrated and you think, wait a minute, life has been on Earth for 4 billion years and language only evolved yesterday, essentially, but on that scale. Why did it take so long? Is a question that people often ask, and it's interesting when you do look at things like dolphins and wolves and many other animals that live in complex groups, and you might think, well, maybe there'd be some advantage for language in those animals, but oftentimes you see that they have evolved down particular pathways that constrain them very, very tightly and make it very difficult to see how they could then go on to evolve a language. Dolphins, so the kind of communication that dolphins use, and wolves as well, of course, is not really very well suited to concrete concepts, to words with semantic meaning and syntactic arrangements. It's a coincidental constraint of the kind of noises they make because they live underwater. People often say that, if dolphins had fingers, perhaps they would develop technology, but they don't have fingers because they've evolved to live underwater. They need their flippers. So they're well adapted to their environment. And they're not trying to become human. It's not like evolution would favor them becoming human-like. No, they're well suited to their environment with all the constraints that gives them.
Yeah. And that's interesting. So the point you made is that for some reason, something happened in the evolutionary tree that somehow just kind of made humans suddenly have this, well, not suddenly, but it seems as if it's quite sudden that we have this ability to think the way we think and communicate and speak, with language, etc. I think I've seen so many crazy theories about that. I mean, like there was a period where I lived in Egypt, and of course, they have the pyramids, etc. And there are groups, people believe that in fact, humans are aliens. So we're not even part of the evolutionary tree. But evolution, because there's so many animals, they've all evolved in a more or less sort of similar rate, etc. But then suddenly humans just came out of nowhere, it seems to them. So they think that it's aliens, and that's where ancient Egyptians are from. I mean, very Stargate, I guess. But also you have, for example, people who follow certain religions. They believe that actually, humans came to Earth, because they came from Garden of Eden or whatever, right? That kind of thing. But I'm just interested. I mean, do you sympathize with these ideas that this sudden, blip or whatever that is, or glitch in the evolutionary tree that kind of somehow made us? I mean, do you sympathize with these ideas? And do you know, or are there any studies suggesting what happened there? How did this happen? Was that still a very big mystery today?
It's still quite a big mystery, but don't forget that we are genetically very similar to chimpanzees. We diverged from chimpanzees 6 million years ago. We still share whatever it is, 98% of our DNA. So even if aliens came and injected some DNA into our ancient ancestors, they didn't inject very much. Okay. We know that. That's something that we can say for sure now, that's not to say that it didn't, it's utterly impossible. I mean, I don't think that, I don't think that it's a serious consideration, but if you remember the movie 2001, The Space Odyssey,
yes,
this black obelisk that imbued the ancient these ancient creatures with some sort of ability to use tools or something like that. It's a fun idea. I think the problem with all of these ideas, of course, is that they're not really necessary. If they were necessary, I'd have a lot more sympathy. If I said to myself, I cannot see how humans could have gone from being what our non-human ancestors were like to what our human ancestors were like. I cannot see how that could have happened. Then I would have more sympathy with these theories. But the fact is, I can totally see how it could happen. It's not that amazing a transition. The fact that we don't know exactly which genetic changes underlaid that innovation is a minor detail. We'll figure it out one day. It's not, it's not that complicated. But when you consider how similar ancient humans probably were to modern chimpanzees in terms of the social structure, in terms of their communicative ability, you can see that I agree there was a dramatic change and a very rapid change, but it wasn't a supernatural. It wasn't a sort of scale at which you have to invoke supernatural explanations. It was pretty much evolution, right? You think about dinosaurs evolving into birds. That's a radical evolution. But we're okay with that. We're happy with that. That makes sense.
Mm-hmm. Now, and that's actually a great point, because one of the reasons why I don't like these sort of ideas personally, because again, it sort of isolates us from Earth. It's like as if, this is not our planet. And as a result of that, you do see people kind of treat and mistreat our environment as if, whatever, it doesn't matter. Let's pollute the waters or whatever, or it doesn't matter that we, if we create building farms, or we're, destroying the Amazon forest or whatever. Well, if we kill a few animals, it doesn't matter. But actually, they're killing millions of microbes that are also part of the ecosystem. It's like, it's that point I made earlier. It's this, that we're somehow exceptions. We're not part of this ecosystem. And I feel like sometimes with people, be it, religious people or people that believe in aliens or whatever, it's like, it's this idea that somehow, Earth, we don't belong here. Do you see what I'm saying? And I think that is wrong, because we do. We are part of Earth. We are part of the ecosystem and part of the evolutionary tree, even if there's these anomalies. But like I said, we're still not that different from the other animals. And as you highlighted earlier, even from the behavioral perspective, we're very, very similar.
Yeah. And I don't think, I'm not sure that this is, although some of these attitudes are particularly common in some religious ideologies. But don't forget that until, 400 years ago, religious ideologies in general were very much telling the story that we were part of the whole world. It's really with the Enlightenment in Europe that people tried to rationalize and tried to explain things rather than just accepting a dogma that they were given. That people came up with this idea, well, we are obviously very different from the rest of the world because we talk and no one else does, for instance. So how do we explain that? And I think that this disconnect from nature really stems from, ironically, it stems from the scientific ability to describe and to classify the world. A peasant farmer in Egypt 1,000 years ago would not have thought particularly about how different we are from the environment. They're subject to the same environmental pressures and rain and no rain, water, no water, food, no food. But then when you had urbanization, when you had the scientific revolution of the Enlightenment, and people started to say, hang on, we are different from nature. What makes us different from nature? That was when humans really started to distance ourselves from the rest of the world. And, at our peril, because any city dweller who relies on their food from the supermarket, doesn't need to think at the moment where that food is coming from. Whereas the farmer 1,000 years ago certainly knew where their food was coming from. And that's where that disconnect becomes dangerous, because people feel that they don't need their environment. They do. They certainly do.
I think that's the weakness that we humans have, is that once we get too comfortable, we ignore reality. We started to, you see that in everything, even now cognitive biases as well, isn't it? It's like once you have an idea that you agree with and you're comfortable with that, you start ignoring all the other ideas. And even now with AI, right? It's like, people already started questioning, why do we need jobs? Why do we need education? Why do we need to do, I'm like, so effectively the technological revolution is actually, it devolves us rather than evolves us, if that makes sense, right? It's interesting. Like, I think the Enlightenment probably could be a reason that we become more disconnected from nature. But it feels to me like as we become more disconnected from nature, we become more disconnected from ourselves. Sounds very philosophical. But because of that, we become less intelligent as a species, interestingly.
Well, we're back to defining what intelligence is, I suppose.
Yes.
And I think what we become less of is less robust.
Yes.
The human race becomes less robust to dealing with changes in the world, and the world will always change. And I think that's the real danger. Now, is that less intelligent? Well, yeah, because one of our abilities, one of the things that makes humans very special is we predict. We use our cognition to predict what's going to happen. And most people would consider that one of the features of intelligence. if you can predict the stock market, or if you can predict, what's going to happen in your workplace, then you're an intelligent person. And if we lose that ability to predict what's going to happen to our ecosystem and to our society, then I think you could make an argument that's a loss of intelligence. Yeah, it's certainly it's certainly an oversight. It's certainly a failure of intelligence.
Yeah. Which I suppose we could probably delve slightly deeper into the meaning of intelligence, because again, there's so many theories, and there's one that I mean, although I'm not sure if he's been debunked. I know he's been challenged. Professor Roger Penrose, where he talks a lot about, from the quantum physics perspective and the subatomic perspective of intelligence, which, I mean, I know nothing. I'm useless with physics, so I can't say whether I agree or disagree. But his arguments make sense. But to me, it's not about the mechanics. He actually summarized intelligence in a way that I feel is just perfect, with one word, and that's understanding. It's to understand things. Like when people talk about AI, that it's intelligent, and my argument as somebody that is involved in AI is that actually, yeah, it's not, because it does not. There's zero understanding. It just regurgitates the data. You feed it the data, it recalculates it and generates more data from it, right? Not necessarily even new data, but it does not understand. There's no understanding. And I think that kind of probably goes back to in terms of whether animals understand their existence, or is our understanding is more evolved than theirs. Therefore, we are more intelligent. So that's why I agree with his point of view in terms of, it's that sense of understanding things. What do you think? Do you agree with that idea?
we do have a problem here, which is that we need more words than we've got. And we want to use a word like intelligence because the term artificial intelligence has become a term and it's got intelligence in it. So we need to talk about that. But on the other hand, I said before, all animals have intelligence, because intelligence is merely their ability to survive in a changing world, to make behavioral decisions in a changing world. I consider that to be intelligence. But what you're describing, or what Roger Penrose is describing, is something different. It's a different phenomenon. And I totally agree. Ants do not have understanding. They can behave in a very intelligent way. They don't have understanding. We know that humans have understanding, or to be more precise, we know that we have understanding. We only think that other people have understanding. And this is something I'm sure we'll come back to and talk about when we talk about chatbots and how you know whether they are any different from talking to another human. If it's, how do you know that the other human knows something? But that's a slightly, that's an easier question to address. No, the problem is that animals are intelligent. Animals perform actions intelligently. Humans do something beyond that. And rather like with that question of language, what are we going to call language? It's a similar situation here. What are we going to call this human ability to understand the world? I don't have a great word for it, because I like to use intelligence for what animals do, because I think it very clearly describes this phenomenon, this trait of making an intelligent decision. Do I go to the left? Do I go to the right when the tiger is coming towards me? I can make an intelligent decision about that. Cognition is another word that's sometimes used, but yes, we're fairly certain that animals, that there are many species of animals that have cognition of some sort. So I think we're lacking in a word for this, for this thing that you describe. There is a word, in fact, that has been used for a long time, and that's qualia, which is used to express that internal representation that we have an internal representation. It feels like something to think about certain things in the world. But no, when it comes to questions of, is artificial intelligence intelligent? I think we need to, maybe we need a better word. I don't know. Maybe we need a better word.
Well, whoever came up with the idea actually regrets it as well. I mean, because like, I had a guest who was Henry Nash. He's a veteran entrepreneur at Silicon Valley, and he's been involved with all these things. And he's like, to him, it's like, when you say intelligent, you mean like what? Like a person? It's like, and some people get excited by that, or they get overly offended by that. It's like, no, he's not like a person. How dare you? Or as we see with the people who are in love with AI, they'll be like, oh my God, not only that it's like a person, it's better than a person. I mean, that's the problem. And I think that's what I've been calling out for a long time. That I think it's intelligence from whose point of view? I mean, from a cat, for example, that could be.
Well, and as an evolutionary biologist, I actually probably not as aligned with your position as you might think, because I look at organisms in the world, and many of them are intelligent. Many of them show signs of intelligence. Some of them have a lot in common with humans. So I can look at the way that a chimpanzee behaves and really sort of see myself in that. And so because we are so closely related evolutionarily, I don't have any problem with saying, I think chimpanzees are kind of intelligent, a bit like humans are intelligent. But then I can look at a dog with whom we share a certain amount of, a certain amount of cognitive mechanism, coming back to this question of what the underlying nuts and bolts are. So we have very similar brains, but they're quite different. So it's quite likely that our cognition is different. And then you think of an ant or a snail, and their neural structure is really very different. And so I feel unjustified in comparing my cognition to theirs. Now along comes ChatGPT, and the behavior is outwardly very, very human. The implementation is very much not human. Can I, in good conscience, say I don't think that ChatGPT is cognitively conscious? I can't say that. I can't, because if I were to rely solely on the nuts and bolts, solely on the mechanism, then that would be then I'd be making a very strong statement. That statement would be saying computers can never be conscious. And I don't think it's at all obvious that computers can never be conscious. If you imagine a dim, distant future with conscious, cognitive, intelligent silicon computers, way beyond what we have. I mean, organisms that are simply that everyone would agree are intelligent. Could we dismiss them because they don't have cells and neurons like we do? I don't think we can. Natural selection works on what it has to hand, and my phone is more computationally complex than an ant brain. So there's no reason that you couldn't, given enough time, given a few million years, that computers could not evolve to be intelligent. And then it would seem churlish to say, no, they're not, because they're not made of the same stuff as we are. So I'm wary of dismissing computer cognition merely because it is in silicon.
For those of you who followed me for a while, you would know that I'm neurodivergent, meaning that my brain is kind of unpredictable. Sometimes it works, sometimes it doesn't. It has its own mind, so to speak. But one of the things that I really did struggle with my entire life, including today, is focus. So I was terrible at school as a result of that. I couldn't focus at university. I can't even focus when I'm working on my desk. And the big problem for me was figuring out ways to help me do that. The strategy that worked for me my entire life was actually music. But I would spend hours, literally hours, figuring out the songs that work best for a particular mood, whether I wanted to focus on something, or I wanted to relax, or wanted to sleep, whatever it is, I would have to find the right song for that. And it kind of worked, though it wasn't predictable. Like I said, I would waste a lot of time trying to figuring out, until I discovered our new partners, Brain FM, who actually used real science to figure this issue out and build an app that creates functional, music engineered to sync with your brain. I'm telling you guys, this is real science, because they actually created a patented approach that as many of your brain cells, your neurons, are bringing all of the electrical signals to focus collectively into that one task that you're doing, or even if you want to relax or if you want to sleep. I absolutely love the interface. It's super simple. You can just choose what it is that you want to do, whether you want to focus, you want to relax, sleep, or meditate. And you can build your own list of some of the favorite songs that they produce. And I have to highlight that a lot of these songs are actually produced by real human composers. And it's lovely, lovely app that you can download onto your computer, your mobile phone, or you can just listen to it online. It's really simple. It's really cool. But above all, it works. If it works on my brain, it should work with your brain as well. So if you check out brain.fm/CEOR, and you'll see a dedicated page to our podcast, and you will get an exclusive, really, really long free demo that you can just download the app and listen at your leisure. No limitations. You can try it for yourself and see if it works. Let me know if it does work for you, because I absolutely fell in love with this thing so quickly, like within a couple of weeks. And I thought I have to reach out to these guys, because also I want to support independent businesses. So check out brain.fm/CEOR, and the big thanks to Brain FM for supporting the podcast. And now back to the episode.
Well, the arguments that I make is that what we have today, it's purely a depiction of our own understanding. I mean, it's very well, ChatGPT behaves like human, or sounds like human, because we programmed it to sound like a human. It's not sort of its natural evolution. It's all fully programmed. I mean, the arguments that I made all the time that, I don't believe AI or computers can ever be conscious in our lifetime. But I believe in the future there might be, because if we following the current approach that we build models, which is basically a depiction of our own understanding, and as we sort of alluded to throughout this discussion so far, we don't understand what intelligence is. Like we can't really figure out the actual meaning of it. I mean, people have different ideas, but even from the biological perspective, we don't know how this thing works. I mean, Penrose's theory could be the right one, which is basically subatomic process. But then, well, how on earth do we even depict that? So for me, I think the only time we will be in a position where we can say, well, actually, we are in a position where we can build conscious machines is when we actually can quantifiably define what consciousness really means. Because then we can replicate it in silico, but then the second challenge that comes after that, and that's a challenge that we've always had with AI, and we still have that today, although it's a lot better today, and that's hardware. So the reason why NVIDIA is exploding right now, because their GPUs are pretty good. 10 years ago, the biggest problems we had with AI isn't it the lack of algorithms. All the algorithms that you see today, I always like to tell people, are the same. Nothing has changed for well over 10 years. But what has changed is the hardware and the compute. We didn't have that 10 years ago, and that was really, really painful. So the question would be then, okay, let's say we figured out algorithmically how to build conscious machines, but do we even have the compute to be able to handle it? Like, I mean, right now we're building acres and acres of data centers that can barely handle ChatGPT. So when it comes to consciousness, for example, I mean, so there's so many barriers for us to cross, for us to go anywhere near this idea of conscious machines. But I would say personally, like as somebody that is involved in both worlds in sort of bio and tech, I believe there could be one day, but not now. We're nowhere near that. Yeah. I don't believe. That's why I find it strange that people think that ChatGPT is conscious. I'm like, no.
Well, I understand. I mean, I do understand because what we have in the world to compare ourselves to is us, other humans, and animals. And when we ask questions of what's conscious, what's not conscious, those are the things that we compare to. A rock is not conscious. We know that. The tree is not conscious. A dog, probably conscious. Those are the sorts of comparisons that we do. So when we come along with something brand new, and it appears to be, in our usual method of comparison, it appears to conform to those criteria, then I understand why people do that. I think, I mean, my personal position or approach to ChatGPT, for example, is that it's an extremely extremely good user interface. And that's what
Yes.
it is.
It's very well designed as an app.
It's a better search engine. It will, and I oftentimes sit and hold engineering conversations with ChatGPT because it's a very good way to get information out of the internet, the sum totality of human knowledge. The best comparison, and it's actually a very relevant comparison, is if you think of Commander Data in Star Trek, The Next Generation.
Yeah.
So who is he? He's essentially a computer that you can talk to. And talking to a computer is a much better way of solving all of these engineering problems. You get Data and Geordie down in engineering, and that well, what do we do now? We try this, we try that. That's very much what I see ChatGPT is doing at the moment. But of course, in the Star Trek universe, Data begins to question whether he is conscious. Now, you claim, and perhaps you're correct, that none of the computing hardware that's currently available could bring us to that situation. But there remains the problem. How do we relate to that situation? Because, like I said before, I don't think that we can exclude the possibility of consciousness merely because the substrate is different from our own. That's the criterion we've used up until now.
Yes.
But if we got to that situation where the computer did ask, "Am I conscious?" I think we'd struggle to know what to do with that.
Yeah. Well, that's the thing. And I think that's one of the reasons why, you see mostly philosophers who say, well, we need to slow down. Maybe we need to kind of think about what would happen if this happens, etc. I mean, because the problem, we have to say, highlight that the problem that the forces behind the current AI evolution rather than revolution, because like it's not a revolution. I say a lot of the models are the same, but it's that because it's so profit driven, and again, it's about power. It's about who, it's like, it's this whole idea. Oh, we're in war with AI war, quote unquote, with China and stuff. So it's kind of like it's this pretty stupid, frankly, a stupid race to disaster just to prove a point. So it's not real innovation where we're saying, okay. Because, for example, like I use another analogy. Like I'm a big critic of humanoids. Like I say they're the most useless robots money can ever buy, because the whole point of robots is that you create robots that can do things that humans can never do. You don't replicate a human as a robot, because then that means that robot will be as useless as a human. However, the research behind humanoids, because I suppose long time ago people thought, we can create a humanoid. Okay, just bring this motorized machine, stick 2 legs on it, and let it walk. And then they realized actually it can't walk. So it opened up this whole massive new research area of human biomechanics, which of course helped people, with paralysis, helped athletes. It opened up a massive new area that I feel like it's fantastic. So that research into humanoids allowed us to understand our own biomechanics. So I'm thinking like, the whole AGI argument. I mean, the way they want to push AGI about, it's like, we can have R2D2. I'm like, I don't bloody care about R2D2. However, but the research itself, because it allows us to ask questions about, what does consciousness really mean?
Yeah.
This research could actually help us perhaps speed our way towards understanding of what consciousness means, what intelligence means, etc. But we need to kind of get away from that crap that we see right now about, this AI war, which hence I'm hoping that the current AI bubble will explode sooner rather than later. It will be painful, because I'm hoping then, hopefully by that point, the grown-ups will be back on the table, or we'll start thinking, okay, we've done the gaming. You lot made money, whatever. Okay. A lot of people lost money. Fine. Now piss off, go back to your bunkers or wherever you came from. Let us start doing the real work. How do we turn this thing into real intelligence that can save, or rather serve science, humanity, etc., etc., etc.? I mean, that's sort of my vision.
But there's one of the things that people forget is that evolution is really, really inefficient. And we have evolved our consciousness and our intelligence and our language over 4 billion years. And it took that long because because it's dumb. Intelligence is dumb. It's just this very slow process of trial and error. And if we try and copy what evolution has done, we will, as you pointed out with humanoid robots, we will end up with a suboptimal solution because all of these solutions are suboptimal. Evolution can only build on what already exists. So there are plenty of examples of weird and peculiar evolutionary solutions because the animal on which the selection was operating was just constrained by something else. And this famous example of this facial nerve in the giraffe, right? Which the nerve goes from the brain, goes down the neck, down the giraffe's neck, around its heart, and all the way back up to the face. Why does it do this? Because when the giraffe was basically a frog, this nerve either went, one side of an artery or the other side of an artery. Didn't matter. It made no difference whatsoever. Yeah. As the neck got longer and longer, the nerve was stuck behind the artery. And so it couldn't jump somewhere else. So it had to it started to loop around that artery as the neck got longer and longer and longer. Evolution comes up with suboptimal solutions. So now we have a problem, because if we copy human cognition and human intelligence, we will end up with that suboptimal solution.
As we see right now, actually.
Or is that a bad thing? Yeah. Well, yes. So we do and we don't, because of course the implementation of artificial intelligence is not I know it's neural networks, but they're really not that similar to the neural networks in the brain. So people are writing, designing algorithms from scratch, not necessarily compelled to be constrained by what has already existed. But that's how evolution works. Again, brains began mostly, the real driver for brains was vision, was for visual processing. Early organisms, as soon as eyes evolved, they needed a good motion detection and shape recognition and things like that. That's what drove the early evolution of brains. And so these systems are constrained by those origins. If you can shake loose of that, maybe there's a better way of designing consciousness. I don't know.
Well, even AI's constraint was basically, as I just alluded to, it's the hardware that we couldn't, for example, even with my startup way back of 2012, we were building language models. They weren't large language models, but it was the same sort of idea. It's like, how do you extract knowledge from whatever data that you get? And again, obviously we couldn't have chat, but we could have so-called smart search. So instead of just using keywords, you can just literally ask a question, sort of human language, as it were. And it then searches based on that and then provides you with the results. And I think that goes back to the point you made about that ChatGPT and other products similar to that. They're brilliant knowledge extraction machines. That's what they're very good at. That's why Google got freaked out when ChatGPT came out the first time. They completely lost their minds, which then that kind of questions like, it's actually their invention. The transformer tech is actually their tech. And the other thing that I challenged sort of publicly, kind of called out Google a little bit, because I was part of the ecosystem as DeepMind and all the others back in the day. Google were on a shopping spree. They were buying out startups left, right, and center. DeepMind was one of them, obviously. They even bought Boston Dynamics, the company behind the famous humanoids that can dance and so on. So they bought all of these models, and OpenAI emerged to counter Google's dominance. Yeah, it was OpenAI that came out with ChatGPT rather than Google. So kind of sort of goes back to the point that I made that we need the big tech to just get the hell out of the way. Maybe fund the work, that's great, but just keep out of this whole idea, because OpenAI did an amazing thing with ChatGPT, I think, in terms of that evolution, in terms of how we interact with machines, that language interaction, which is a dream for those who who are not involved in tech. The biggest dream that we geeks had for decades is having the ability to converse with machines. That was always a thing. Like you've seen that even in sci-fi movies. Now we can't do that because of the large language models, which is great. So what's the next step? I mean, I think that, as you said, the environmental constraints that we have right now are hardware. But my concern is that as we're, because of this current stupidity that we see in the commercial AI world, is that we're getting more and more AI slop. So we ourselves becoming constrained in terms of our knowledge, our ability to comprehend reality, which is another problem.
Yeah, maybe, but I'm less pessimistic because, we had slop before. The moment that the internet became widespread and everyone had access to everything that everyone has ever said, then what are people using it for? Mostly for consuming things that are untrue, things that are irrelevant, things that are slop. Now, if ChatGPT can allow us to use the internet better, then in many ways it actually could be an antidote to the sort of cat video situation that so many people lament. If it means that we interact better with all this huge amount of knowledge that we're presented with, I don't know. I'm interested to know what you think about the Turing test. Was Alan Turing completely wrong? Was he simply wrong?
I don't believe he meant it to be as a test, because I believe it was more of a point that he was making, that there will be a point where humans won't be able to tell the difference between a human or a machine when they interact with it. But the thing is, in the world of AI, we always use the Turing test as a way of how do we fool people in believing that they're dealing with a machine or not. I mean, so it's a different dynamics. I mean, I made an argument I can't remember which episode recently, that I feel we need to get rid of the Turing test idea completely, because the way people look at it, they think about, okay, how do we make AI like a human? And my argument, I guess, from the scientific perspective is actually, forget that. Forget humans, right? You're kind of like with humanoids, right? Forget that. How can we build models that can help us do the things that our brain can never do? So searching the web, that's great. What about, for example, what we had in the 90s, where we had bioinformatic techniques, with less capabilities that we have today, yet we managed to decode the entire human genome. I mean, no scientist could have done that on their own, right? But we still needed the geneticists to do it. But because we had that ability to achieve this phenomenal capability, or rather discovery in genetics, amazing. That's AI. That's where AI excels at everything. So for me, that's the argument that I'm making. Forget the Turing test on whether or not, it's like a human. I don't care. Does it help us? They go on about, let's use AI to cure cancer. Okay, ChatGPT ain't gonna do that. You need a whole dedicated model for that. Or even actually, that's something I wanted to ask you. I mean, do we have the AI that would allow us to potentially even communicate with animals, or translate animal communication to human language? That could be a possibility. I don't know. But are you involved in anything like that? I know you're using a lot of AI in your research, but I'm just interested to know which areas you use AI in.
Yeah, and I am involved in that mostly in quite a critical way. And I think the big problem with animal translation is that it presumes there's something to translate. It presumes that there's something that is a language. And as I said, I think that animal communication is firstly relatively low in information, but also rather imprecise. So the kind of translation that you're going to get is not going to be the kind of translation that you get from Google Translate. It's not going to be a sentence. And I know there's a lot of work on dogs using these little push buttons to make sentences. I'm not going to go into that, but that's not the way that animals communicate in general. Now, could you use AI to give you a description of the emotional state of an animal from its communication? I think that's more than possible. People have been working on this kind of thing, like interpreting dog barks. There are angry barks, there are happy barks, there are nervous barks. That sort of thing can be done, and it can be done quite simply. It's not something that requires the kind of artificial intelligence that is at the forefront of AI today. I work on, I'm part of a competitive award for people who have found AI, who found translation solutions for animal communication. If you can, which scientists have really advanced that goal of understanding the communication so that humans can really perceive what the animals are saying. And there's some good work that's being done, but it's a very different, it's a very different sphere from the kind of AI that is driving, as you say, the humanoid, the human-like communication. And I think that, to come back to the Turing test, the reason that it was proposed, the reason he proposed it as a test was not just that at the time it seemed unlikely to happen, but also that from a philosophical point of view, you have this solipsistic philosophy. How do I know that you are actually conscious? I do not know that you are conscious. I know that I'm conscious. The only way that I infer that you are conscious is that you behave like me. I ask you questions and you reply. And that is deeply unsatisfying to philosophers. And so when it's...
Sorry to interrupt, because you can fool it. Yeah, because you can fool people. Like, say, you can depict.
You don't even need to fool it. I mean, this is ever since Descartes first proposed this. He said, "How do you know that it's not just a demon that is impersonating, that is deceiving you? That all of your senses are just a deception. Everything is a deception. You may be the only organism, only individual in the universe, and everything that you perceive is just a deception, and you cannot disprove that." Which is why this idea of assessing whether another individual is conscious or not by your interaction with them is so deeply unsatisfying. And I think to some extent Turing probably had a little bit of a tongue-in-cheek when he made that, because we know that's not a good enough test. It's not a good enough test for humans. The difference with humans and with animals, if someone says to me, as some people believe, animals are not conscious. Animals are simply, you're just being anthropomorphic. Animals are not conscious. Doesn't matter how they behave. They're different from us. And this is sort of the converse argument. But what we do when we think about humans, when we ask ourselves, are humans conscious? Is we have this conversation and we say, okay, this person is reacting kind of like me. So I think there's probably something inside their head. They're probably conscious. But I know that their brain is physically similar to mine, and their DNA is physically similar to mine. So the most parsimonious explanation is that they are conscious, because their mechanism of consciousness is so similar. When I look at a dog, as I said, our brains are somewhat different, but I can accept that a dog or another animal is conscious because they have that similar infrastructure, the similar processing infrastructure. So they have the behavior that indicates they're conscious, and they have the hardware that is similar to my hardware. I'm comfortable calling them conscious. And that's where the Turing test falls down, because you can't do that with a computer. And we're back to the Cartesian problem of maybe it's just an illusion. Maybe it's not real at all.
That's interesting, because as you were describing it, it reminded me of the example you used in your book of the parrot, that famous parrot, Alex. That, because if we're going back to language, because if some people can relate consciousness to language because we have the ability to speak properly, etc. Therefore, we're more conscious, we've got better understanding, we're more evolved, etc., etc. But can you actually explain how a parrot like Alex did what it did? Or it's a he, I guess, right? So how the hell did he manage to do these things? Because it's I don't know. He's like the Michael Jordan of parrots or something.
Yeah, it's a big open problem in the investigation of animal cognition and animal communication, which is that there are some species, not many, but then we haven't tried very much. There may be more. There are some species that appear to be able to learn human language. done with Alex the parrot. It's been done with chimpanzees to some extent, bonobos to some extent, dolphins to some extent, that they seem to have the ability to learn human language, but they don't use it. There's no doubt that parrot communication in the wild for sure, and almost certainly dolphin and chimpanzee communication in the wild, it's not language. Okay. That's my position. Some people disagree, but with parrots, I think we can be fairly confident that that's not language. So what's going on here? An organism has the ability, but doesn't use it. And this is really, really, really interesting. I mean, I think this should be the forefront of animal communication research and evolution of language research. It's implying that all of the building blocks of language are very widespread. They're present in many, many species. There's probably something, there's probably some little key that's missing in parrots and in chimpanzees that mean they can't really learn full language. I mean, Alex, he undoubtedly communicated linguistically, but that's a long way from saying he could write a book or understand poetry or something like that. So there's clearly something missing, but so much is there. So many of those building blocks are there. And this is hugely fascinating. Why is that so widespread? I mean, we have a sort of hypotheses, but it is a remarkable observation.
Could you explain, just for the listeners who might not be aware of what we're talking about, people haven't read the book, but what was so special about Alex specifically? Well,
so parrots mimic a lot, of course, and everyone knows that parrots mimic, and if many people have this particular kind of very, very vocal parrot, the African grey parrot, and they're fantastic mimics. I mean, these are the ones who you see in the news that they hear people in the zoo swearing, visitors, and then they start swearing back and things like that. They're fantastic mimics, and being a mimic is a big part of who they are as animals. It's a part of that's unquestionably part of their needs in their niche.
It's part of their survival mechanism, I believe, right?
It's essential
to hide away from predators and stuff like that. Apparently, yeah.
Well, or to cooperate in their flocks and
as well,
be able to live in a group. But what happened with Alex was that the professor who was working with him managed to train him to understand human language in a way that was not mimicry, and to use human language in a way that was not mimicry. So he could construct sentences. He could construct new sentences in a way that could not be explained simply by copying or by getting used to something or by giving a reward and things like that. This was actual innovation. So for instance, I mean, the example that I give, the one that I think is the most impressive, which is not, perhaps linguistically the most impressive, but cognitively absolutely incredible. That if I were to have a tray of wooden blocks, for instance, and I would take any animal, a dog, a pigeon, doesn't matter. I could probably train that animal to respond appropriately and count how many wooden blocks there are. It's not that difficult. Most animals have some numerical sense. So, you could show this animal and say, how many wooden blocks are there? And the animal says 3. Now, if it's a pigeon or a dog, they'd have to find some other way of communicating. With a parrot, it can actually say 1, 2, 3. So that's why parrots are a useful target. So there's nothing special about that. But if I show Alex the parrot a tray with blocks that are the same shape but different color, so some red squares and some blue squares, and I ask him what's different about the blocks, and he says the color, that is something you cannot train an animal to do. That is something that is reflecting an underlying cognition. And the fact that not only that he had that cognition, but that he could express it verbally is really very, very remarkable, very exceptional.
Yeah. Well, that was the the basis of the post I made, that that AI is not stochastic parrots, because parrots are smarter, because AI, even when you ask that question to ChatGPT, it does not understand the question. It's simply a statistical calculation to your prompt, and it says, yeah, they're different colors. But in there, it suggests that that Alex actually understood the question, understood what he saw in front of him, and he responded accordingly using a language that it's not his language, that's remarkable for sure, isn't it? That's crazy, actually.
It is remarkable, and it is crazy. I'm going to push back again, though, I'm afraid, on the ChatGPT, because the reason that you don't like to compare the ChatGPT's response to Alex's response is that you know how ChatGPT works. You designed it. You know what's going on there. And we don't know how Alex arrived at that response. And so it's somehow mysterious. It's somehow unexplained. It's somehow perhaps deeper. But as an evolutionary biologist, this is a mechanism that has evolved without design over millions of years and has come up with that result. And if the same evolutionary process had resulted in a ChatGPT, which it hadn't, but if that were to happen, why would I think that the two are any different if they could both come from that? So I think we have to be a little bit careful about the fact that we understand how AI works makes us treat it differently than animal consciousness, which we don't understand. They may not be that different for all we know.
So basically, it's not a conclusion that Alex understood then. So basically, from your point of view, he didn't understand the question necessarily. Like, could that have been an accident?
I would say he did. I would say he did, in the same way that I think my dog understands when I am happy with her or excited or angry with her. I think there's genuine understanding there. Now, part of the reason that I think there's genuine understanding is because, as I said, I know the neural substrate is similar to mine. I know I have understanding. I know I've got a brain. She's got a brain. So perhaps there's something similar going on. So it's a stronger argument in that case, because we have some of the mechanistic, some mechanistic justification. But the fact that whether or not, I can't explain what understanding is. I can't say that I know that this is that one thing is understanding and what ChatGPT does is not understanding, because I can't really explain what understanding is.
Well, that's what I suppose I'm kind of sort of centering it around Penrose's definition, I guess, which is, again, obviously, as I said, it's not sort of 100%. It's just like, to me, it kind of makes sense in my head in terms of like how, I see intelligence in general, not like in terms of being clever, but it's like, I understand what's going on more or less. It's that self, like, as you mentioned earlier, it's that sort of sort of that sense of self and others and self understanding, my place in the world amongst other people and animals, etc. So it's much more complicated, which actually brings me nicely to, again, a thought process that came to my mind just now, that, with Alex, for example, and parrots, because you mentioned earlier that effectively all animals, us included, we evolved as per the constraints of the environments around us. So, dolphins could have evolved further than where they are right now because they're in water all the time. So does that mean that, let's say, if parrots had the same sort of evolutionary, or rather less evolutionary constraints that humans had, could they have evolved into something like a human in terms of cognition and language?
No,
it's a crazy question.
No, it's not a crazy question, but it is a question that's important to shut down very, very quickly, because there's nothing special about humans, about the sort of human endpoint. It's certainly not the case that dolphins or parrots somehow are striving to become like humans. The human situation, this human endpoint that we have now, is a very specific response to the very specific conditions that our ancestors experienced. And because of those conditions, they evolved certain solutions, and here we are today. That was then. Okay. That was them in their environment. Dolphins, parrots, chimpanzees are not in that situation. There's no pressure for them to become more like humans. It's no advantage to them. When you ask yourself, why did it take 4 billion years for language to evolve? One answer you might give yourself is that language is rubbish. Maybe it's no good. I think there's a lot to that, actually. I think language is a very expensive thing to maintain. Our brains, our huge brains are largely devoted to language. And
Yes.
why do you need it, right? Why would an animal waste so much energy and so much of their body for something that maybe doesn't help them all that much? So really, it's more that our ancestors were the weirdos. Our ancestors were unusual in that they could have benefited from language, whereas most other animals, it's just not that useful. It's not that useful, and that's why it hasn't evolved.
But it's about survival again in the wild, isn't it? Like our language ability will help us survive in the wild, would it?
Well, it did, presumably, at some point, but again, we don't
Somehow,
really
yeah.
know
Yeah, at
what
some
it
point.
was about our ancestors that led them to be favored by this new trait.
I guess you see my question is suggests this inherent idea that we're better than the other animals, and hence we ask that question: why aren't they as good as we are? And I think that kind of proves the point I made. It's like I did, subconsciously we think like that animals are beneath us, right? That we are this ultimate evolutionary gift or whatever, which of course we're not, I guess.
No, we're really not, and we feel that way partly because it is true that language has given us an ability to essentially to dominate the world. I mean, we've spread over the planet in a way that is absolutely exceptional. Absolutely. No other organism has done that with that. One other organism has done that. The blue-green algae that
oh yeah
3.5 billion years ago that made the atmosphere full of oxygen. That's the sort of kind of scale of change to the planet that we're looking at. So we are unusual in that sense, but no, there's nothing special about us in terms of where evolution is going, if you see what I mean. That is not, that's definitely not correct. And as I said, all organisms on this planet have been evolving for exactly the same amount of time. They're all just as evolved as each other, and suited to their environment.
I had a crazy question. Another crazy question that popped in my head. Where do you think evolution will go, say, in the next 4 million years? I mean, from
human
the
evolution
patterns that you've seen, well, human or animal. I mean, do you have any models, or your team, do you guys come up with any sort of models that say, okay, this is what we think how the evolution kind of in the last 4 million years brought us to where we are today? So do you have a model that suggests what's the next 400 million, or rather 4 million years, how humans would evolve or animals would evolve? Assuming, of course, that we didn't kill the Earth completely.
Well, I was going to say, unfortunately, the models that we have are not very promising. And that is because when you look at the pace of climate change and of environmental change, most species on the planet struggle to evolve to keep up with change that is that rapid. So I would say the most reliable prediction is that we will see substantial destabilization of ecosystems, mass extinctions, a collapse of productivity and diversity on the planet, and it will be a very, very marked period in Earth's fossil history. When people look back in 400 million years, they will see this and think, wow, that was bad. So much of Earth's diversity was lost during this period. What will happen to humans? Will humans be able to survive it? I think it's possible. I think it is possible. It's so hard to say. It's such an unpredictable place to be in. Humans interestingly, although of course humans are still evolving biologically, everything is, but what we perceive is not our biological evolution, our cultural evolution. It is the rapid spread of ideas. Ideas come, ideas go, ideas mutate and take on new forms, and that is what is really changing rapidly. But you can't get away from the biology, and we still need to eat. And if our ecosystem collapses, then that's going to be very problematic. I suppose your next question is going to be, will we ever become like cyborgs? Will we be able to upload our consciousness into machines, which is another sort of sci-fi trope that people often think about.
Well, that's what
the answer to.
well, that's certainly what the likes of Peter Thiel seems to want to see. It's like they seem to, that they're not just talking about it. You can tell that they want that to happen, which is, and he would describe, actually, I kind of made a post about that on LinkedIn recently that kind of went viral a little bit, where he kind of describes people like me as the Antichrist. And I'm like, wow, okay.
Yes.
I was like, so I guess he will call you an Antichrist as well, because how dare you say that, humans aren't going to evolve in a way that he thinks they should be evolving. But I don't know. I mean, what sort of timelines you're talking about here? Because obviously, we are seeing evidence that the environment is literally collapsing as we speak. There's this horrible storm in Jamaica right now, or hurricane, the worst in history. Again, like every year we seem to be getting more and more of these, worst in history storms. Like in the UK, for people who don't live in the UK, we used to get heat waves once every few years or decades. This year we had 3 in one season. In one summer, we had 3 heat waves, which is like, that's in the UK, as a supposedly cold country. So obviously, the environment is obviously in a very bad place. But do your models suggest what sort of timelines that we're talking about here in terms of how quickly
it's not really my field. So I don't have specific models, but what I can tell you is that whenever you model complex systems and destabilization of complex systems, and particularly the rapid destabilization of complex systems, you often see a situation where the collapse of the system is utterly unpredictable. So you can push a system well beyond point of collapse, and it won't collapse, and there will be no warning when it does. So unfortunately, we could be 100 years, 500 years, could be 10 years. We just don't know. But I think, I don't want to be too much sort of prophet of doom. As for humans evolving and becoming, machines, part machines at least. And this touches on my other book, actually. So one of the things that you often hear science fiction theorists talking about, or even people who think about life elsewhere in the universe, is surely, given the age of the universe, surely other civilizations are more advanced than us, or at least there are some other civilizations that are much more advanced than us, not just 100 years, but maybe 1 million years more advanced than us, or 100 million years more advanced than us. And if you think about what AI would be like in 1 million years, it's an inconceivable amount of time. But I think even you would agree that in 1 million years, AI is going to be pretty good.
It could be something that we don't even know. It might not even be AI. It would be something,
exactly.
I don't know.
But then the argument goes, then these should be the dominant life forms in the universe. These will be such effective, such intelligent, such foolproof systems that they will come to dominate the universe. And when we go and find life on another planet, we're not going to find bacteria. We're just going to find robots. So this is an argument that many people make. Of course, the big problem with that argument is, where are they? If the universe is covered in all of these super powerful robots, they've never come here. So it seems like perhaps even 1 million years of AI won't actually help that much. But it is a point of contention, a point of discussion.
Yeah. Well, I would argue, I mean, like a million years from now, we don't even know what technology would look like. So perhaps, I think, was it Brian Cox, I believe, that made a point that if some civilization in the universe has that level of capability, we wouldn't even know if they are in here. They probably are here. Maybe they've got some kind of nanotechnology, robots or whatever that are surrounding Earth, and we don't even know. We think that they're not here, but probably they are here. How did like the typical sort of tinfoil hat type arguments is like, yeah, the aliens probably are living amongst us, and we don't even know. But actually, scientifically speaking, maybe if they're 1 million years ahead of us.
Well,
like, I don't know.
Again, I take the evolutionary perspective on this, and I think that we would recognize. I think that we would. I think there's there are still rules about what life can be, and there's still rules about how life can propagate and develop, and even in a universe full of artificial intelligences. Even in a universe populated by robots, there will be competition between the robots. Therefore, there will be selection. There will be evolution. You can't escape from the basic laws of how life works just because you are a million years more advanced than we are. A million years sounds like a lot for us who've only had computers for 100 years, but in the scheme of how long life has been on Earth, it's really not that long at all. Things don't change that much.
Yeah. Which actually brings me nicely to the second book, or it's actually your first book. I haven't read it, but I want to. I will do that. It's the Zoologist's Guide to the Galaxy, because one of the things I sort of alluded to this point, because one of the things that fascinated me with genetics. And again, for those who don't know, I learned how to code when I was about 10 years old. So that was like in the 80s. So my father was an engineer, so we had access to computers and all of these things. So I kind of played around and I fell in love with it. But the thing that fascinated me when I started learning genetics and bioinformatics in the 90s is that when you look at genes, it's a code, right? And it's like, to me, it's a code, and it's not sort of just random. There's logic. It's almost like an if statement, right? If this gene happens, you generate these molecular structures or these protein structures. Else, do that, right? It's almost like, it's obviously not that simple, but I could see patterns like this, and I thought to myself, somebody must have written this code, right? So again, I'm not religious. I don't. Obviously, the religious folks say, "Oh, it's God." I'm like, whatever, I don't know. But the point is, there's certainly, going back to the point that you made earlier, that there's a template that we all kind of seem to be following, right? But I feel like this template, this intelligence, I guess, is throughout the universe, because like NASA have found almost identical elements on Mars that we have here on Earth. So obviously we all come from the same templates, even beyond Earth. And that's why I think your book is fascinating. Like is it exploring that sort of similarity? Like, is zoology more or less universal beyond Earth?
Yeah, that's very much the point. I mean, I think that this idea that DNA is so impressive, someone must have programmed it. Just remember the giraffe's neck, okay? DNA is actually a really rubbish way of programming. If you were designing life, you would not design it that way, okay?
I never said it was a good code. I said it looked like a code.
Yeah, but it is because it has evolved through natural selection. That is the only way that complexity can accumulate on its own. Either complexity is there because it's been designed, or it's there because it has evolved. Those are, and that means that we've got a set of very, very clear rules that all life in the universe follows. Now, you say quite rightly that NASA has found chemicals that are the building blocks of life, as they say it. But we also need to remember that these chemicals are very common. These are very simple chemicals. And yes, they are throughout the universe. That doesn't mean that there's life throughout the universe, but it means that those building blocks are there. They always have been. Simple chemicals like ammonia, which can be used to make amino acids. Water is unbelievably common in the universe, incredibly common. So So there's a lot of stuff that other planets have in common with Earth. But the thing that will be the one that makes things recognizable and similar is natural selection. That is the mechanism. That same mechanism will occur everywhere. Won't necessarily be DNA. DNA is not necessarily the only way to do it. Probably not the only way to do it. There will be some kind of code because that information needs to be there, and it will evolve in probably in very similar ways to the ways it did on Earth.
Again, depending on the environment of the planet. If the whole planet is just made out of water, then it's just going to be dolphins, basically, isn't it?
Yeah.
Yeah.
But then, yes, I mean, of course, life on Earth only moved on to land. Well, animals only moved on to land really very recently, 450 million years ago, something like that. So there's most of the evolution of life on Earth was in the water.
No, that's fascinating. Fascinating. As a way of sort of ending it, I always like to ask the story of all the guests that come here, because we do have a lot of young people that like to listen to this podcast with a typical question that I know as a professor as well. You probably get these questions all the time, like, oh, I don't know what to do with my life. I just finished my degree, or I'm about to finish my degree. Like, I think we've all been there. Well, I definitely been there. So how did you decide to, I mean, zoology is such a massive, massive field, but what attracted you towards trying to understand animal language? And I know you've done your PhD on that, and you chose hyraxes out of all animals, which is like, I thought, okay, this is random. I understand why, because obviously you explained. But how did you even find out about hyraxes for you to do a whole PhD on that?
Yeah, I can't give advice to people because, of course, everyone is different, and everyone has different constraints and different things that motivate them. But I certainly have had a very varied career. I mean, I moved from one field to another field, and as things interest me, and I think you've got to be interested in what you're doing. I think that is. I mean, it sounds
absolutely
trite,
fundamental,
but
yeah, no.
And not being scared to follow what you're interested in is really important, and that comes into play in that particular story of the hyraxes, because when I started my PhD, I was not working on animal communication. I was actually working on population dynamics and movement mostly. So I was looking at how hyraxes move through the environment from one colony to another, and particularly looking at disease transmission and things like that. Because I had come from a much more algorithmic background. So mathematical biology and algorithms and models and things was my thing. So I thought we'll do models of how these animals feed and move, and how that affects disease spread and things like that. But they just make so much noise.
But why hyraxes specifically in this particular area then? Why hyraxes specifically?
I was in Israel, and they're very common. They are everywhere. It's very easy to work with. It's always good to choose a subject that's easy to work with. At the moment, I'm off to Vietnam to work with gibbons, or Nepal to work with tigers, and to work with wolves all over the place. So it's not always the ones in your back garden. But if you do have an interesting animal in your back garden, it's very helpful. So, and they're incredibly interesting. I mean, they're very interesting in terms of the population. So I was sure I was going to do that, but they just make so much noise. They make so much noise, and you cannot study them without thinking, why are they making all of this noise? And then it occurred to me that was a really good question. Right? That actually was a more interesting question about. And in fact, what my PhD was on was a mixture of the two, because I started looking at their sounds and see how the sounds move between different colonies. So it was more about the learning, the cultural learning. You can have disease that moves between colonies. You can have individuals that move between colonies. Turns out you can also have songs that move between colonies. And so it was a very easy transition, that one, actually. But yes, it was just thinking, you know what? Here's a more interesting question. I want to answer this one.
Yeah, you mentioned in your book that effectively they have like different accents, isn't it? Because of their different locations. So it's like the sound different depending on where they are like on a valley or something like that, right? It's like they literally have accents, which is like, that's so
Sure,
cool.
because they learn. I mean, there are many animals that learn their songs. And when you learn a song, you make mistakes, and then those mistakes become part of the song, and then someone else copies from you, and so on. So these differences accumulate, and it's quite common in many species, actually.
Wow. But then how did you have to sort of live in the wild with these animals, like for you to be able to observe them? Because I can only imagine it's an impossible task, isn't it? It's like, it's so hard to do that.
It is difficult. It is difficult. And this is one of the reasons why I work with animal sounds, because even when you can't see the animal, you can often hear them. So one of the reasons, for instance, that we still know so little about wolf behavior, wolves, which are a very well-known animal, is because they're often around at night and you can't see them. I mean, it sounds ridiculous, sounds obvious, but it's true. So all the observations that are done of wolf behavior are done during the daytime when you can see them. What do you do at night? They're very active at night. Well, one of the things you can do is you can listen to them. You can listen to the sounds. But you're absolutely right. I mean, it's really difficult. And as I said, I'm off to Vietnam soon. We're working with gibbons there in the mountains, in the jungle, and it's incredibly difficult. It's incredibly difficult work. It's just getting to this remote site is very difficult. And then you have to hope the gibbons come and you can see them. It's very challenging. Yeah. It's not an easy job. I'll put it that way.
Yeah, and you have to, because you have to set up camp in the wild and you have to basically stay there for a prolonged period of time. I mean, how often, like, sort of what's the typical time frame that you spend? Like, how long do you stay in these places?
I do have a day job, so I do teach at the university, so I can't really be away. But during the university vacation, then essentially that's when I go and I spend the whole vacation in the field doing field work, maybe a month at a time, if I'm lucky. Yeah.
And is that a team? I presume there has to be a team.
Yeah. Oh yeah.
Okay. Yeah. For safety reasons, surely. Yeah.
Well, safety and lots of skills, lots of people, each with their own skills is really important. We have lots of local people we always work with. We've got fantastic local conservation teams who do incredible work. And we're really just sort of bringing them extra tools to help them to do this. They're really the focus of what's going on, and we then provide this sort of the extra dimension of what we can do with the animal sounds.
Yeah, no, that sounds phenomenal. I mean, I love nature, and sometimes I envy the work that you guys do, because I know quite a few other zoologists. Like, sort of when I lived in the Middle East, they used to go to the Saharan desert, which is like crazy hot, but they want that, study the ecosystems in there. I'm like, it's a Saharan desert. What are you talking about? but it's phenomenal stuff. And I think, of course, now with AI and the evolution of AI, and you alluded to just now that, your background does involve a lot of data, maths, etc. So that kind of brings me, to the final question. So what is the future of zoology? And where do you see AI basically fitting within that now? Because obviously we're talking about animal communication, but where do you see, maybe biology in general moving forward with the technology that we have today? Again, post the AI bubble. I mean, once that crap is gone, we'll have real AI that we can start focusing on.
No, actually, zoology is on the verge of a major transformation, and that major transformation comes from data. So I make it sound difficult when I say, we have to hike up these mountains in the jungle and things like that. But the reality is the quantity of data that we can gather now is so many orders of magnitude more than we could ever do in the past. I might gather, on a short field trip, 5 terabytes of data, something like that. Huge amounts of data, the kind of data that you cannot possibly analyze manually. So we are in a position where the technologies, acoustic technologies, drone technologies, there's a lot of work done with drones and imaging, a lot of work with satellites, other kinds of sensors, generating huge amounts of data over large areas. And now we need to process it. And the sort of the dream application would be, here's a patch of jungle. I can know where all the animals are in that jungle and what they're doing from all this remote sensing. That would be
Mm.
a tremendous revolution, but it requires very sophisticated data processing techniques. And that's where we need to leverage AI. That's what we want to get AI to do, is to help us to analyze the data, which is already phenomenally large quantities, but it's only going to grow. It's only going to get bigger.
Mm. So what sort of breakthroughs you're hoping to achieve?
Well, I think so. One of the things, my main project at the moment is using tiny AI. So having very small sensors. Actually, I have one here. It's not that small. A relatively small device. It's mostly battery, to be honest, because it has to be out there, with a large battery. But have a very small device, very small computational device, doing data processing in the field, because I cannot take terabytes and terabytes of data back to my university and then you run some huge computer. The analysis needs to be done where the data is being collected. And I think that's the big breakthrough. If we can have intelligent devices that are analyzing the data on the spot and then sending us the important parts of it, then we've really cracked a new way of monitoring the biological world.
Well, that's the thing I've been calling for. I mean, I'm a big fan of this whole concept of on-device AI. I mean, I don't like the idea of what we see with the data centers. They're so centralized because, firstly, I mean, there's security issues, privacy issues, whatever. But from the reality point of view, if you want AI in the field, like you highlighted, you can't use data centers for that. What if the satellite crashes? Then what? So on-device AI for me has always been the way forward, and I think. That's why I actually commend Apple that they seem to be moving in that direction on their phones. That they, the Apple, aka Apple Intelligence, they had to obviously call it Apple Intelligence. Like it's mostly on the phone. So I think that's, again, for me, that's where the useful AI, can play a big role in society and science for sure. So no, that's cool. So that, it proves the point that we've been talking about. So, are there any future books coming?
We will see.
Have to read that
working
one,
on it. Yeah. Yeah. Always working on it. I love writing books.
Is there a secret, or can you?
For the moment, a secret. But it'll be be the same on. It'll be about what we can learn about ourselves from looking at the world. This is really what everything I write about is about. How we are part of this sort of this one system that has achieved everything that we see around us through these amazing simple mechanisms.
No, well, amen to that, and I think we all need to do that. I think I think we probably respect the environment more if we thought in that way, that we're all part of the same environment. So. No, that's fascinating. Thank you again. Thank you for your work. Thank you for your time. If people want to find out about your work, where can they go?
Well, they can just Google me, or use ChatGPT. I don't know which one is better. Yeah. So
that's hallucinate.
Yeah, my books are published by a mainstream publisher, so by Penguin, so you can easily find them. Zoologist Guide to the Galaxy and Why Animals Talk. And I'm at the University of Cambridge, and so you Google me and you'll find it.
Cool. And there are links that I'll put in the description for everybody to see. But Arik, thank you so much. Really appreciate your time.
Thank you.
Fascinating discussion.
It was great.
Well, my friends, this is it. I hope you enjoyed this conversation. Thank you so much for joining us. Now, before I go away, if you are on YouTube, please make sure that you hit the subscribe button below. It really makes a massive difference for the growth of our channel. And if you're following us on Spotify or Apple Podcasts, you need to give us a star review. Apparently, your following means nothing unless you give us a star review. Don't ask me why, but give us whatever star review that you think is fair. And if you're not following us, what are you doing? Come on, man. It doesn't cost you anything. It really makes a big difference. I really, really appreciate your support. But also, if you've got cash to spare, consider to become a founding member. We are an independent medium. We're not reliant on any kind of company that gets money from Russian oligarchs or any kind of weird sponsorships or anything like that. All of the companies that work with us are genuine companies that I know and I like. But ultimately, it's the members, you guys, our subscribers, our followers, our founding members, or those of you who actually just donated us like $1 here, a couple of bucks there, $5 there. All of that makes a big difference. This is what makes us truly independent. We're not chasing clickbait because we don't want clickbait. We want facts. We want the truth. We want something that we can all aspire to and something that truly make us at least work harder to make the world a better place. Not just talk about it, but actually make it happen. And of course, it supports all of our campaigns as well. So my friends, thank you so much. Much love. And I'll see you in the next one. Peace.